Welcome to part 2 of the semester 1 final review packet. So in number 6, we're looking for y, and we see that we have y's in the denominator or bottom parts of fractions on the left side of the equation. So a good thing to try first is to multiply both sides by that variable. So in this case, we're going to multiply both sides by y. So on the left side, when we distribute the y, it cancels out with the y in the bottom part of the fraction. So we get 17 plus y plus 32 plus y equals 100y. Combining like terms on the left side, we get 49 plus 2y equals 100y. And then we'll subtract 2y from both sides. 49 equals 98y. And our last step, we divide both sides by 98. And we arrive at our solution that y equals 1/2. Number 7, solve the system of equations. So we can use substitution or elimination on this one. I'm going to go ahead and use elimination because I see that the coefficients for the y variables are the same in both equations. So what I'm going to do is I'm going to subtract the two equations. When I do it, I get x minus x squared, which cannot be combined. The y's variable is eliminated. Negative 4 minus negative 2 is negative 2. So at this point, we have a quadratic, and we need to solve the quadratic. Let's see if we can factor it. So what I'm going to do is I'm going to subtract x and add x squared to both sides of the equation, so I get 0 on one side of the equation. That is necessary when you solve by factoring. Looking at the quadratic, can we find two numbers that multiply to negative 2 and add to negative 1? Well, the answers are, or the numbers are, negative 2 and positive 1. Setting each factor equal to 0, we get 2 and negative 1. Now, we are not done with this problem. We just found the x-coordinates for 2 points of intersection of this line and that parabola. We need to find the corresponding y value in order to write the two ordered pairs which represent the solutions. So I'm going to use the top one, x minus y equals negative 4. I'm going to go ahead and plug 2 in for x. Oop, you can't see that. So I subtract 2 from both sides, and I get y equals 6. That means 2, 6, that ordered pair, is one of the solutions. Now, for the other solution, I'm going to plug negative 1 in for x. Negative y equals negative 3. Y equals 3. So the other solution is negative 1, 3. Now, as a good check, you can always plug the x and y values into both equations and make sure that they satisfy both equations. Okay, number 8, use a quadratic formula to solve the equation, then verify your solutions graphically. Okay. So here we see our A is 4, our B is 16, and our C is 15. And here's the quadratic formula. Make sure that your division bar goes all the way to the negative b, because that is also divided by the 2a. So we get negative 16 plus or minus radical 16 squared minus 4 times a times c, all divided by 2 times 4. Okay, so inside the radical you get 16, and we divide by 8. Well, since radical 16 is equal to 4, we can rewrite this as negative 16 plus or minus 4 divided by 8. So, solution number 1, negative 16 plus 4 divided by 8, 3/2. And then for the other solution, sorry, it's negative 3/2, we get negative 5/2. That looks better. So graphing it, we'll go ahead and plug in 4x squared plus 16x plus 15 into the calculator. We'll look at it in the standard viewing window, and we can see that, yes, it looks like it goes through negative 1.5 and negative 2.5, which corresponds with negative 3/2 and negative 5/2. So for the sketch, I know it's kind of cramped. It's going to sketch the parabola. Okay, number 9, solve the inequality and graph the solution on the real number line. When we have an inequality, we want to get 0 or keep 0 on one side of the equation. So we are not going to add 2 to both sides. Instead, we need to find a common denominator for the left side of the inequality. So what I'm going to do is I'm going to multiply both the top and bottom of the fraction by x plus 1. Really all I'm doing is multiplying by 1. So now my common denominator is x plus 1. I get x plus 6 minus 2x minus 2. Combining like terms, I get 4 minus x over x plus 1 is less than 0. So any sign changes will occur when the top's equal to 0 or the bottom is equal to 0. So let's go ahead and find those critical numbers. So my two solutions are positive 4, 4 minus 4 is 0, and negative 1. So those 2 points divide the number line into 3 intervals. So over here you see the 3 intervals along with the critical numbers. Now, for each interval, we're going to pick a point in the interval. Hopefully it's something easy to work with. So I'll pick negative 2 for the first interval. The critical number, we'll just check that number. I'm going to pick 0 for the middle interval, and I'll do 5 for the top interval, or the right side interval, 4 to infinity. So all we do is we're going to plug these numbers into this side of the inequality and just see, is it positive, negative, 0, or undefined. So if I plug negative 2 in, I get 4 minus negative 2 over negative 2 plus 1. Now I really don't care what it's equal to. I just know that the top is positive and the bottom's negative. So in that interval, the left side of the inequality is negative. If I plug negative 1 in, I get a 0 in the denominator, so it's undefined at x equals negative 1. Middle interval, I plug in 0. I get 4 divided by 1, which is positive. I plug in 4. I get 0 on the top, so that one is 0. And I do the same thing for 5. Negative divided by a positive is negative. So which of those intervals are less than 0? Well, we see from negative infinity to negative 1, and from 4 to infinity. Sorry, that's supposed to be negative 1. Since the boundary numbers are not in the interval, we'll put open circles. We'll shade to the left from negative 1 and shade to the right from positive 4. Now, as a check, you can go ahead and graph the inequality. So notice I've typed in the left side of the inequality, and I'm going to go ahead and graph it. So, does our answer match our graph? Well, we see that it looks like it's negative below the x-axis all the way to about 1, negative 1. And then here, it's negative again, and 4 seems like a reasonable boundary. So this graph is a good check for our solution. Okay, determine if the equations represent y as a function of x. So recall, for a function, for every one number we plug in for x, we can get at most one answer for y. No matter what I pick here for x, I'm going to get one answer for y. Let's take a look at the graph. So to get the absolute value, you push the math button, and you go to number, and you choose the first one, absolute value. 4 minus x. So when I graph it, we see that it does pass the vertical line test. The fact that we could actually plug that equation into our calculator tells you it's a function. Your calculator will not let you graph a non-function into y1. So y equals -2. That's simply a horizontal line. So both of those are functions. Okay, that's it for part 2. We'll start with question 11 in part 3.